Engineering Skills Academy. We are available at Dar es Salaam, Tanzania, East Africa. You may contact with us through phone number +255 737 72 1910 or +255 787 85 74 85. Email us kirumbiengineering@gmail.com. Website kirumbiengineeringacademy.ac.tz. Now you can pass through also the specification of the material, the class, the FCK, and the properties generally, whether it is plain concrete or reinforced concrete or pre-stressed concrete. So go and pass through on this table. You can have good knowledge regarding to the specification of the concrete, depending on the class and the characteristic strength and the nature of the concrete, whether it is plain or reinforced or pre-stressed concrete. So pass through on that one. You can gain the specification, how it appears. Now the specification of the material or the concrete, it is this function. So also it is depending on how the corrosive condition, the chemical attack, the mass of the section in casting, and the high strength, whether it is hardened or low heat or blast furnace or denser, so etc. So you can look on this one also affect the specification of the concrete. So pass through, you can look how it is affected to each other, and this is very important to know the radiation, the light, the displacement, cementation, etc. Now the steel, specification of the steel, whether it is hot or cold. So for all size you can look, and the specification, the characteristic strength about it. This one always in BS or whatever can use up to 460, but in Eurocode it is recommended about 500 Newton per millimeter square, and this is the characteristic strength for the steel. But in BS you can go up to 450, 460. I mean you can lower it. You can lower it up to 460. But in Eurocode you go up to 500. So pass it through in order to understand the characteristic strength of the specification of the steel. So it means the gauge strength is about this one to this one, but in Eurocode it is previous, always they use 500, but in the other way you can use up to 460 on designing, and it depends whether it is hot rolled or maybe steel or it is cold hold. So it is you to pass it through and to look which kind of steel you use on your design specification. So generally, as we said, that is the specification of the steel, it is functionable on this way, and the bending radius is about 2.2 times the bar diameter, and it should not be less than 16 millimeter. So this factor passes through, and you can look the importance for each one. Now also the material of the reinforcement, it is classified as the grade. So there is grade R, which normally associated with a small diameter, less than 12 millimeter. It is lower in ductile. Will include the limit in the moment distribution in which it can be applied, the high quantities and fire resistance. This is class A. So also there is class B, mostly common used as a reinforced bar. Also there is class C, in which it has high ductile. So this it can withstand even the earthquake. So it depends on the nature and the area where you design and the nature of the. So in Eurocode, you can pass through and you can look this one, and these are the family. Eurocode at 1990, the Eurocode, the basic strengths of the structure design. Eurocode 1, the action of the structure. Eurocode 2, the design of the concrete structure. Eurocode 3, the design of the steel structure. So it is categories depend on which kind of design, whether it is a timber or the masonry or whatever you want to design. So the specification of the code of the standard, it depends on which kind of your structure you want to design, whether it is a timber or steel structure or composite structure or whatever. So you can pass through and select the actual standard you want to use. It depends on the your structural integrity of the members. Now, different terminology. The terminology in Eurocode versus British. In Eurocode, the action, while in BSc standard, we use the force or the imposed displacement. So in Eurocode, we replace it by saying the action. While in Eurocode you use the so-called verification, while in British standard you use it to check. The check whether it is successful or not successful. So in Eurocode you use the resistance, while in British standard you use the capacity. Here we use the execution, while in BS you use the construction stage. So here the permanent action, in BS we use it as dead load. Also, the live load in BS or imposed load, in Eurocode it is used as a variable action, and isostatic here is called the primary load. So these are general terminology which we use several in our design, and it is compared, or it is compared depending on the standard or BSc standard or Euro standard. So the code of practice will vary or will have its name or terminology, but the meaning is the same. So once we say the action, it means the force. Once we say the verification, it means the check. Once we say the resistance, it means the capability. Execution, it means the construction. The permanent action, it means the dead load. The variation action, it means the live load. The isostatic, it means the primary load. This is the difference between the Euro and the BS in terms of terminology. So also the design life as per Euro. So the design life, design working life in category, indicated design. So category 1 is 10 years, and this is the temporary structures. Category 2, it is about 10 to 25, and this replaces the structure part 1. So the gantry, girders or bearings. Category 3 is about 15 to 30 years, and this is the agriculture or similar structure like that one. And the category 4 is about 50 years, and this is the building structures and the other common structure like that one. And the category 5, it is estimated about 100 years. This is the monumental buildings, structures or bridging structure and the other civil engineering structures. So most of these it depends on your design of your structure and its nature in order to estimate how long the lifespan of your design. So the symbol are so common, so pass through on this one. You can have a different symbol and how it is represented. So the way how it is presented is like that one, and these are different symbols you can use on representation once you are going to design. So in this symbol is as per this clause, can refer there, you can have there the partial safety factor, etc., etc. symbols. So different symbol there. These are different symbols. It depends on the use and how it is represented. Now chapter 2. Chapter 2 are the limit state design. Now the limit state design, a condition of a structure beyond which has no longer fulfilled its relevant design criteria. Now the condition, you say that it is a degree of loading of the structures. Now the criteria, it is the structural integrity, fitness of the use, durability, or other design requirement. Now, a structure is sustain all action. In BS we say the forces, like to occur during its design life, and to remain a fit for use within appropriate liability for it as a limit state. Now the introduction. The introduction have the condition, the requirement, a limit state, and that one FSO. Now what this loading? The structure should be, the requirement should be safe. The ultimate limit state USL in Eurocode, I mean for the dead load it is 1.35 GK, while for the live load or action load it is 1.5 QK, and this is as per and this is as per the Eurocode. For the Eurocode we use 1.35 GK, while in BS we use 1.4. It is estimated 1.4, and this should be estimated to 1.4. 1.4. This is about BS. While in Eurocode it is 1.35 GK. The same applied for the live load. This is estimated to be 1.5 QK, while for the for the BS it is about 1.6 1.6. So it depends on the code of practice. Once you use the Eurocode, the values for the safety factor, which is 1.35 GK for the dead load, and 1.5 GK, 1.5 QK for the live load. But in BS we say this is about 1.4 and this is about 1.6, and this is for the resist loading. But normal loading, the member does not distract from the appearance, the durability, and the performance. So the limit state, this is serviceability limit state, it is assumed to be 1.0 GK and 1.0 QK. And this should be very understandable because it is usable in designing in several cases. So whether we design it as limit state or serviceability limit state. For the limit state is 1.35 in Euro and 1.4 for the BS. And here is 1.5 for Euro and 1.6 for BS. Now, the introduction. The three basic methods usually for the factor of safety to achieve, it is under this method. Now, the first one, permissible stress. Now, the factor of safety or material strength or factor of safety, it is limited by this one. Whether it is simple but it is inconsistent, no longer in use, it is based on the elastic stress distribution, not applicable to the seismic plastic material or concrete, and not suitable when it is the deformation are not proportional to the loading. It means like a slender column, unsafe when dealing with the overturning force, and this we say the permanent permissible stress. But also the so-called loading factor method, and this is loading working times the safety factor, and this is like this limitation. So the limitation it is in this category once you use the loading factor method. Also the another the another one is by considering the limit state method. Once you consider the limit state method, it is the working load times the partial factor of safety or the material strength. So if you consider under limit state, it means you take the working load times the partial factor safety. So, and these are consideration like this one. Apply the partial factor of safety for both the load and the material strength, but more flexibility. So in general or in summary, these are the three conditions which you can take which approach, either it is permissible stress method or load factor method, but in general we consider as under limit state method, in which the working load times the partial factor of safety. So pass through on this one, you can aware on which condition your design or your assumption is taken about. Now the limit state. The purpose of the design is to achieve the acceptable probabilities that the structure will not become unfit for its intended use. Now, if you consider the acceptable probabilities, means you must consider your structure should not be unfit. It means your structure should be safe for the intended use. And this I saw the limit state or not reached. It It means the two types of the limit state is as follows. The first is ultimate limit state. The requirement: the structure to withstand the loading safety against the collapse, the possibility of the buckling, the overturning accidentally, and the damage of your structure. And this consideration is named as you consider under limit state design. But once you consider under serviceability limit state, and this must be limit stated that can affect the appearance, efficient durability of your structure, as well as the comfortability of your occupants. For example, you design your structure. After completing your design of your structure, your structure, say your slab, it is deflecting. Means if it is deflecting, it means your structure is not comfortable, because it is deflecting from horizontal. Now it is deflecting, it is become uncomfortable. So once you consider the durability, I mean the ultimate limit state, so you must have considered the appearance of your structure, the efficiency, the durability, as well as the comfort of your structure. And these are the so-called ultimate, I mean the serviceability limit state. So generally, once you consider the serviceability limit state, these factors should be considered in your design to be safe. So the deflection check, the cracking, durability, excessive vibration, fatigue condition, fire resistance, and the others. So generally, if we consider more, even the earthquakes, so is you to take place or to take into consideration under that circumstance. So the two situations should be considered. The first situation, as I said, the ultimate limit state, and the second is the serviceability limit state. Also, the characteristic strength. Now, the characteristic strength, we say this is the material strength, unlikely to be lower than its value. Now, the assumption of the strength of the material is normally as have the maximum mean strength like that one, and you have lower about 5%, and you have considered not above 95%. So the value is between 5% to 95% here. And here it depends on the number of specimen versus your strength. So the characteristic strength, it is the function of mean strength minus 1.6 times the standard deviation, and this is, you can get your characteristic strength of your material. So generally, the characteristic strength, it is a function of this formula. Now, the characteristic strength can be obtained from this table 3.1, which you can have your characteristic strength depend on the classes. So you can pass through, you can have your characteristic strength as how it is being estimated as far as it is obtained as per the table. For the general formula, as we stated above, it is the function of F min minus 1.6 times the standard deviation. Also, the action, the characteristic strength action or the force should be equal to the force of the structure to be designed. Also, the characteristic action or the characteristic force is like this one. The maximum value, it is about F min plus while the minimum value it is about F min minus, and this is depending on the most cases or most continuous, and these are from the graph, as we said, should be between lower 5% not exceeding 95%. The value for the lower, the value for the maximum. The action or the force is about mean at the middle there. So the numbers and the action. These are the forces versus the numbers. So the graph is like that one. It means if you want to estimate the maximum value, it is the function of F min plus. The minimum value it is the function of F min minus. The partial factor of safety. Now this causes the errors or inaccuracy. Now the design assumption, once it is inaccuracy of the calculation, so the partial safety factor, it cuts off the possibility of an usual increment of the magnitude of the action or magnitude of the force. You can assume your building or your structure as residential, while on use it can be used as a store or whatever. So that is unusual increment of your magnitude. So this cut off by the partial safety factor. So the partial safety factor has got big or many uses. So the first one, the second one, the unusual magnitude, the unforeseen, and the construction of inaccuracy. You can construct, you can estimate grade 30, while on construction the grade is, after measuring or after 28 days, it is lower than grade set. So that is constructional inaccuracy. So most of these one are cut off, or they say the partial safety factor, it is the tolerance applied to the material strength and the action, or the action means the force. So the means or the meaning or the use of partial safety factor is to cut off all these ones. So generally, we say the partial safety factor, it is a function of characteristic strength or the design strength. It is a function of characteristic strength over the partial safety factor. So in terms of action, the design strength, it is Fk times Fy. It means the partial safety factor times. This is by the design action, and this is by material way. Then in terms of material, you divide. In terms of material, you divide. But in terms of force, you times. So it is matter of you. So once we say that the design action or the design force of the dead load is 1.4 times a partial safety factor. It means the design load times the partial safety factor. The same applied the live load. It is a design load times, the load times the partial safety factor. That in terms of force, but in terms of material, you divide. Now the partial safety factor of the material is like this one. Now the compressive stress, it is FCK over partial safety factor, while the partial safety factor as per that clause or as per that table for the concrete is about 1.5, as we said before. The same applied. Once you want to find the design strength for the tensile, it means the reinforcement bar is the same FCK for the tensile over the partial times this value here. So the FCK, as we said, it is the characteristic strength as per this table, and this value is 1 recommended, or it is variable. It depends on the table value. So generally, the partial safety factor, as we said, it is this value here. This is for the concrete under accidental or not accidental, and this is for the steel bar, and this is the pre-stressed steel. So it depends on the how you use. If you use, it is design situation and the condition. Now it is patient, it is normal use. Transient means the temporary condition, e.g. during execution or repair. The accidental, it is means an exceptional condition, like in under fire or explosion or under impact, or the consequential failure. So this is, it depends on how the assumption you assume under normal circumstance, or under temporary condition, or under accidental condition. So whatever your assumptions, the partial safety factor you can take it depend on design assumption. Also, the partial safety factor, as we said, it depends on this situation. So you can pass through here and read how you can use the partial safety factor. Essentially, check for the equilibriums, check for the structure, and alternatively. So the value is this one. So generally, if we consider for the unfavorable is 1.35. This is per Eurocode. While for the BS we estimate is about 1.4. The same applied for the Eurocode for the live load. It is about 1.5 for Eurocode and 1.6 for the BS. So pass through on this. You can read it well, and you can adapt whatever your assumption you want to take and under what conditions. The value is there and the table, so it can be easy to know. The same applied. This is under limited state. This is under limited state. So under ultimate limit, the values can be also obtained. This one, the value under serviceability is 1 for the dead load, which is permanent load as per Euro, 1, and the variable load, which is we mean live load as per BS, it is 1. So the same applied. You can take there this table to know which condition, whether it is permanent, dead load, or variable load, live load, or whatever. So the situation is depending on this one. You can pass it through, and you can load and which condition you want to use and for which uses, whether it is secondary or primary, like a wind load or whatever. Your consideration or design can be taken into considerations. So this is very important and very crucial to understand whether it is permanent and which use or examples. The permanent load is like a self-weight, the finish, whatever. The variable load or the temporary load is like a temporary load which is imposed, like a traffic of the people, wind, snow, etc. These are not permanent load. So this is important to understand. Also, as we said, the partial safety factor depending on the use and whether it is GK or QK. Pass it through and take your appropriate partial safety factor under ultimate, which is gamma F, also under serviceability. As we said, under serviceability, it is generally 1. Now we come to the partial safety factor under action. This one, it is if we consider as favorable or unfavorable actions. So the condition to know this is favorable or unfavorable is like this one. Now take the condition. if with the conditions, the condition and here the effect, if we consider it as favorable, it means decrease the loading acting on the structures. But if we consider as unfavorable, it increases the loading on the structures. And this is the conditions, the one which you can have your partial safety factor to be considered as favorable or not favorable. So these are very important to understand, the conditions and the effect of the load. So if you know the condition and the effect, whether it is increasing or decreasing, you can consider either it is favorable or not unfavorable. So these are also another situation in order to consider or to select the material. So we can proceed with these examples. Email us with kirumbengineeringskills@gmail.com, website Kirumbe Engineering Academy@ac.tz.